Alright, welcome to Mancinelli's Math Lab. This was a requested topic. I proposed it, and enough people liked it that I think it's worth going over. I want to go over a specific reserving technique called the chain ladder method. So this is the most basic method, I would say, and it is one of the techniques used for predicting or projecting ultimate losses. So what's the idea, basic idea behind reserving is that say you're an insurance company, you need to set aside some money or some assets that will cover your future liabilities because you want to remain solvent. Okay, if you're over reserving, that could be a problem because you're setting aside money that could be used to cover expenses. It could be used for investing, so that's an issue. If you're under reserving, then you don't have enough money to pay off your debts, so that's definitely a problem as well. So either way, it's an issue. So we want to get our reserve estimates right, if possible, but they're estimates. So how can we estimate the ultimate losses using this technique? So this is called a developmental triangle, or this is called a reported loss triangle, I should say, in this case. And what are reported losses? So reported losses are just the paid losses plus case losses. So a claim may have come in, and the claims adjuster decides we need to set aside some money. Some of this money will be paid immediately to the insured, and some of this money, that's the paid losses, some of this money will be set aside in order to eventually be paid to them. That's the case losses. Okay, and these things are updated, right? So that's what reported losses are. And so in our case here, and I'm assuming that we're in calendar year 2010 quarter one. So that's why I have that right here. We're assuming that we're in the time 2010 quarter one. And that's what I have right here. 3 months out of 2010 is 2010 quarter one, right? So, excuse me. I just need to drink some water. All right. And so if we look back, we have our data, our historical data. If we look back at, say, accident year 2000, first of all, what does it represent? This row, row 4, these are the actual reported losses corresponding to accidents that occurred in 2000. So according to our historical data, 328 reported losses happened within the first 3 months. Then, also corresponding to accident year 2000, we have 778 reported losses 15 months out. And these are cumulative. So actually, what's the change, the difference here is how much of these reported losses actually happened in 15 months out. And we keep going. So once we get to 27 months out for accident year 2000, we have 1,178 reported losses, etc. Now notice that once we get out to 111 months out here, we see that hopefully these reported losses are fully developed. And we're hoping that we're not going to have to report anymore. Now they could change depending on different things, but I'm not going to go into that. Okay, so we have those accident years, and we just do this. We have this for each of these, right? And hopefully you see actually that what calendar year is this number in? 2578. This is 123 months out for accident year 2000. This puts us in the current calendar year and quarter. So this is basically represents the reported losses for accident year 2010 today. Right, because I'm assuming we're in calendar year 2010 quarter one. This diagonal actually represents calendar year 2010 quarter one. So hopefully that makes sense. Okay, and now The underlying assumption of this method is that losses will develop according to how they've developed in the past. So we're using historical trends, historical loss development patterns to project how will losses today or more recently develop. And the way that we quantify that is with using these development factors. So here are my link ratios, and these are also just development factors. And what these represent, 2.37, this is just the quotient of 778 divided by 328. So this number right here represents the quotient of 778 and 328. So what we're saying here is basically, this gives us an estimate of how reported losses 3 months out from an accident year develop to the next year. So according to historical data for the accident year 2000, multiplying 328 times 2.37 gives me 778. This gives us an idea of how those losses are developing. And similarly, we can just go down this. So this is nothing confusing really. These are all just the quotients. So this is 2.32 is just 790 divided by 340. 2.24 is just 814 divided by 364. 1.3 is just 1528 divided by 1178. So we're getting each of these numbers is representing basically, for instance right here, 1.3 is saying how have reported losses developed from 27 months to 39 months for accident year 2010. All right, so hopefully that makes sense. So this is our developmental triangle here, our loss developmental triangle. And from this, we get averages. And the reason why we're doing these averages is because we want to, again, say we're looking at 3 months of development, which is corresponding to the current calendar year, and also accident year 2010, quarter one. We want to say, how much has this 363 developed? Well, this is in developmental period 3 months. All of these cells in column 1, from row 18 to row 27, these all represent historical trends for which these represent how losses have developed from 3 to 15 months. So each of these potentially could be used to help us indicate how will this 363 develop if I put it here? Like, in other words, what will this number be? How will the reported losses have developed? I mean, we basically have a choice. I mean, which one of these will we use? That's why we take averages. And I think it makes sense to give the more recent data a heavier weight because hopefully that's more accurate. That's maybe more accurate about how things have been going. So what we'll do here is we'll take different types of averages. We may have the 3-year volume, we may have a 5-year volume, we may have a 3-year simple, 5-year simple. Sometimes the geometric mean is also given, the square root of the product. So these are it's just 2 averages, and I'm here, for my purposes here, I'm just selecting actually the 3-year simple. Now don't be thrown off here. It looks like these are exactly the same. It looks like the 3-year volume and the 3-year simple are exactly the same, but they're not. If I change how things are rounded, here, then you'll see that these are actually different. So notice those numbers are actually different, right? The farther I go out, the more those change. So those averages are not the same. But for our purposes, just trying to keep things simple, I'm taking my selected average. These are the ones I'm going to use. I'm going to use row 33. And how do we get the selected? Actuarial judgment. Experience. So we're taking row 33, and these are going to be the ones I'm going to use, actually. These are the developmental factors I'm going to use to project my reported losses forward. So in other words, what does this 2.31 represent? This represents, if I multiply 363, this is the reported loss in calendar year 2010, quarter 1, corresponding to accident year 2000. If I multiply 363 times 2.31, that will give me what I then estimate for the reported loss, cumulative, for 15 months out of 2010, right? And if I took 1.51 and multiplied by 791, right, this is the loss development factor saying, how do we get from 15 months out to 27 months out? Well, these things develop by a factor of 1.51. So if I take 1.51 multiplied by 791, that will give me this entry here, this estimate of what these reported losses in accident year 2009, what they will be when they've developed 27 months out. So hopefully you're getting the flavor there. And we just keep going. So now because, because, for instance, for 2010 quarter one, I'm not just interested in how they developed to the next period. I want to know, what is the value going to be once it's fully developed, once it's way out here. I want to know, what are the reported losses going to be once they've basically been exhausted, once there are no more losses to be reported. So what I want to do is I want to multiply 363 times 2.31, then take that, multiply by 1.51, take that, multiply by 1.29. Again, I'm getting these numbers right here. This is telling me how these losses are developing. So I'm looking right here, and I'm just multiplying those. That's why I have what are called the CDFs. The CDFs, which again, they're not the cumulative distribution functions. These are the cumulative developmental factors. 7.38 is the product of 2.31 with 1.51, go all the way down this row. What does that represent? Think about what I just said. 7.38 should give me an estimate of the reported loss in accident year 2010. It will give me an estimate of what this reported loss will be once it is fully developed. This 7.38 is the factor, the developmental factor, which will give me an estimate of the reported losses for accident year 2010. I want to know what they're going to be at the end, right? Once they're fully developed, that's what that will give me. So I hope that makes sense. And that, again, I mean, the logic there is just, it's corresponding to these selected LDFs, right? If I multiply 363 times 2.31, it gives me the ultimate here, or it gives me the reported loss here. Multiply by 1.51, that will give me the ultimate here, etc. And 7.38 is the product of all these. So it's doing the exact same thing. So again, just to illustrate further, what would I use 3.2 CDF for? That would give me the projected fully developed loss corresponding to accident year 2009. So in other words, if I multiply 3.2 times 791, that will give me an estimate for how much this reported loss will be once it's fully developed, once it's way out here, once everything's happened, right? So I hope that makes sense. So that's the idea. And now I'll just do what I just said. So I'm going to take my recent reported losses. Just think about this intuitively. What should recent reported losses be? This is just saying, well, what year and quarter are we in? What I said for this example is that we're in calendar year 2010, quarter one, right? What are the recent reported losses? It's just the diagonal. It's just this diagonal. These diagonal entries are the recent reported losses. Again, we want to get an estimate for what these reported losses will be once they're fully developed. This one is already fully developed, possibly. According to the historical data, this looks like it's fully developed. This one looks like it might be. According to the previous year, accident year, it looks like it's been fully developed, but maybe it needs to be developed more. This one probably needs to be developed more, etc., right? So I take my recent reported losses, that's just the diagonal of my reported loss triangle, okay? And then I multiply them by the CDFs, as I mentioned. So as I mentioned before, taking 3.78 times 3.63 gives me an estimate for my projected ultimate loss. So again, to reiterate, what does this cell represent? This represents basically how much we need to reserve, how much we need to store away that will cover the reported losses from accident year 2010. Based off our historical trends, we think, using this specific reserving method, that for the losses in accident year 2010, that they will develop, when they're developed fully, that we'll get this numerical value of 2680. For accident year 2009, remember that this 791, this had already developed one period, right here. I want to know what will be its projected ultimate loss when I go all the way out. In order to do that, I use this particular CDF. So that's what I've done. So this number, 2532, is the product of 791 and 3.2. So take these, multiply them together. This gives me an estimate. This estimate represents how much we need to set aside to cover our reported losses for accident year 2009, etc. Notice, go all the way down here. Go all the way down to 2000, the year 2000. And these losses, as we saw, according to what we have, the data says is that these are fully developed. We have 2578, and there's nowhere else for it to go. That's it, 2578. All right. The last thing I wanted to basically share, so that gives us a way. That gives us a way to get the projected ultimate losses. And actually I have one more row. What's the IBNR? Incurred but not reported. These are just basically, what are incurred losses? These are just basically the amount, incurred loss for the insurance company in this case is just what amount they have to pay out. Those are the incurred losses. So for accident year 2010, we had incurred losses of 363. But our projected ultimate loss for accident year 2010 is 2,680. So what are the losses that are incurred but not reported? Well, it's just the difference. We think that this number will be incurred total, and this number have been reported. So incurred not reported, but not reported is just 2,680 minus 363. This is my incurred but not reported. These numbers are important, right? Because these are basically represent what are the reported losses that we're eventually going to have to pay out. And so as you can see for 2000, hopefully we're not going to pay out anything else, because everything for the year 2000, it's far enough back that hopefully it's fully developed. All right. So last thing I wanted to share is just, and this is important, this last bit, because we want to know how stable is this method. So in other words, right now we're determining these projected losses as of the year, the calendar year 2010 quarter one. What would they have been if I had predicted them, if I had estimated these ultimate losses, say in calendar year 2009? And actually, I can change this. I can change this to reflect that. And that's what I've done here. And this is, again, this isn't, these numbers are not, of course, accurate, really. I mean, they just made these up. I mean, I gave a little bit of thought to them, but what if I change this to 2009 quarter one? Notice my numbers change. This projected ultimate loss changed. Actually, let me do that one more time. So let me go back to 2010 quarter one. The ultimate loss was 2,680. So this is our estimate for evaluation period for today, for 2010 quarter one. What if I think about like what would the estimate have been had the present time been 2009 quarter one? It drops to $2,427. So if we're in calendar year 2009 quarter one and we run our estimates, notice that these are all a little bit lower. So based off historical trends, we get a lower projected ultimate loss than before. And then we imagine a year passes, and now we're back in present day, 2010 quarter one. And now our projected ultimate losses are 2,680. Think about it for a second. That can be an issue, because basically what that's saying is that for accident year 2010, we did not set aside enough money. And so that's what I have down here. So I have my charts. Okay, so I have three of them. I have 2007, 2008, 2009. So what is this saying? This is saying that if we're in calendar year 2007 quarter one, and I project my ultimate losses for that accident year, what would they have been? they would have been about 2,150 or so. This represents what I would have projected as my ultimate losses had I been in calendar year 2007. A year passes, I do the estimate again, I use the chain ladder method, I run the whole analysis again, I get my projected ultimate losses for that same accident year, 2007, and I say, what are my ultimate losses now? Well, damn it, they're 2,300. That means if I'm the insurance company, I need to set aside more money. That's not really good, because we weren't right. Of course, these are estimates, but I need to set aside more money the next year. Another year goes by, it's now 2009 quarter one, and this is saying I need to set aside even more money. I'm setting aside more money as time goes by. I'm saying, as time goes by, my estimate was too low. I needed actually to set aside more money to cover the reported losses for accident year 2007. Finally, I get to the current year and I say, damn it, I was way off. I actually need to set aside almost $2,600 to cover my 2007 accident year losses. And I look along 2008, same idea for 2009. So that's not what we want, right? And of course, management and everything's probably not going to be too happy about that, because they want you. What would be the ideal situation? The ideal situation, hopefully, you'd say to yourself, is that that these bars would just be level. Let's say that the actual ultimate losses are 2,600. Then what we would hope is that our projected ultimate losses, each evaluation period, each calendar year and quarter, would be around 2,600. Then we would say, well, that's great. We estimated these losses quite accurately. And furthermore, if they were level bars like this, we wouldn't have to keep setting aside money, more and more money, to cover what we think these reported losses will be. All right, so that pretty much does it. Again, this is a very basic overview of the chain ladder reserving method. There are several different types of reserving methods, and hopefully you can see why, because if I just ran the analysis for this method, we're not getting very good estimates. What we would say actually here is that this chain ladder method is unstable. We want these to be stable, we want these to be flat. So we may want to resort to other reserving techniques that will hopefully give us a more stable projected ultimate loss. So I hope you found this helpful. I think this was a good idea because for people entering the profession, you really have no idea what goes on. So this is one of the more traditional roles that an actuary has, is reserving. So please give the video a thumbs up and tell me what you think. And thanks for watching.